So let's talk about the ellipse. So if I take 2 points and I label it F1 and F2, and then I take a line from F1 to a certain point and then F2. This is some distance D1 and some distance D2. If I look at all the points in the plane where D1 plus D2 is equal to a constant, then I've traced out all the points that are in an ellipse. So since D1, so why don't we take this point as XY? This point right here, we're going to negative F, comma 0, and this is at the point F0, and we have the origin smack dab right there in the middle. So this is the point XY, so if I look at the distance here, so this distance here is X, that distance there is Y. So if I look at the bigger triangle here, where this height is Y, this is D1, and this distance length right here is X plus F. Then I have a formula for D1. D1 is the square root of Y squared plus X plus F squared. If I do something similar for D2, this distance is Y, this is D2, and this is X minus F. So D2 is the square root of Y squared plus X minus F squared. Now the total distance, since I'm looking at an ellipse here, if I look at this extreme point, make this extreme point A0, and because of symmetry, negative A0. Then if I look at the ellipse, and so I have my 2 points here. So I'm basically, my D1 now is this distance here. My D2 is that distance there. That distance is A. This distance from here to here is F. And this distance from here to here is just A minus F. And again, because of symmetry, this is A minus F. So D1 plus D2 in this particular location is F plus F plus A minus F plus A minus F. So F plus F plus A minus F plus A minus F. This right here, this part here is D1 and this is D2. Well, that just is 2A. And since the sum of D1 plus D2 is a constant, and all we need is to find one location to find that constant, and so this is equal to 2A. So I'm now going to isolate one of the radicals. So I have the square root of X plus F squared plus Y squared is equal to 2A minus the square root of X minus F squared plus Y squared. So flipping over, in essence, I've got this plus that equals 2A, and I just subtracted that from both sides of the equation. Within the radical, I flipped around the order in which I'm adding, but we end up with this. I square both sides, so I have X plus F squared plus Y squared equals, so I'm squaring both sides, is equal to 4A squared minus 4A square root of X minus F squared plus Y squared plus X minus F squared plus Y squared. Simplifying this down a little bit, this is X squared plus 2XF plus F squared plus Y squared. That was this, is equal to 4A squared minus 4A square root of all that plus X squared minus 2XF plus F squared plus Y squared. Let's get rid of what we can. Y squared cancel out, F squared cancels out, X squared cancels out. Adding that to the other side over here, I have 4XF is equal to 4A squared minus 4A square root of that. So I clearly have 4 in every term, so I can get rid of the 4's. And I want to isolate the radical again. Ultimately, I'm trying to get rid of the radicals. I'm trying to, deriving what I consider the standard formula. I have it written slightly differently. of what they consider standard. So isolating that, so I'm going to let's flip sides for these. So I have a times the square root of x minus f squared plus y squared is equal to a squared minus xf. I can leave the a there or not. I'm squaring both sides again. This will get rid of the final radical, so I have a squared times x minus f squared plus y squared is equal to a to the fourth minus 2a squared xf plus x squared f squared. Inside here, I have x squared minus 2xf plus f squared plus y squared. Distributing the a squared, so I have a squared x squared minus 2a squared xf plus a squared f squared plus a squared y squared equals a to the fourth minus 2a squared xf plus x squared f squared. I do have one thing in common on both sides. I have that and that. So I'm going to get the x terms on one side, and so why don't I bring this over to here and that over to there. So I have a squared f squared plus a squared y squared equals, minus a to the fourth equals x squared f squared minus a squared x squared. I can factor x squared out over here, and I'm left with f squared minus a squared. And then over here, looking at these two right here, I can factor out an a squared from those, and I'm left with f squared minus a squared plus a squared y squared. That stays there. So we can simplify that. Actually, we've got some space over here. If I look at the ellipse again, make this the point 0b, and this is the point 0, negative b, and this is still the point a0, and this is the point negative a0, and I have my two lines right there. I know if that's d1 and d2, I know the sum is 2a. So d1 plus d2 is 2a. And looking at these triangles here, if this distance here is f, because that's the point f0, and the height there is b, then d2 is the square root of f squared plus b squared. And because of symmetry here, because this is the point negative f0, so that distance there is f. d1 and d2 are the same thing, and so 2a is equal to 2 times the square root of f squared plus b squared. And so we can get rid of the 2. So a squared is equal to f squared plus b squared, or, switching places here, f squared minus a squared equals negative b squared. So our equation here, I'll just rewrite that equation. I had a squared, f squared minus a squared plus a squared y squared is equal to x squared, f squared minus a squared. Well, I have a shortcut there, so this is negative a squared b squared plus a squared y squared equals negative x squared b squared. Get rid of the negative signs there by switching places, so I have x squared b squared plus a squared y squared is equal to a squared b squared, and then divide both sides by a squared b squared. And I'm left with, well, for this term over here, the b squareds cancel out, so I have x squared over a squared plus y squared over b squared, and that's equal to 1. And that is a standard form for an ellipse.